Hi, everybody, and welcome to this new episode of SageMaker Fridays. My name is Julian, and I'm a principal developer advocate focusing on AI and machine learning. As usual, please meet my co-presenter.
Hi everyone, my name is Ségolène and I'm a senior data scientist working with the AWS Machine Learning Solution Lab. My role is to help customers get their ML project on the right track in order to create business value as fast as possible.
All right, thanks again for being with us. So where are we in this season? This is the first episode of the automation sequence. And so today we're going to start discussing ML operations, deploying endpoints, monitoring models, building pipelines, etc. Okay, so we have 4 episodes. Automation in general. Super, super important topic. Okay, and we have 4 episodes, and then we'll dive into AutoML for the end of this season. So still quite a lot of ground to cover. So again, we are talking about the music recommendation example, which we covered a few weeks ago. So Sego, tell us a little bit about that. So, just in case some of you didn't watch that episode, right? First episode in season 4, exactly. Go and watch it, okay? We're revisiting the example and zooming in on different things. So tell us about it.
So yes, exactly, Julian. This week we are going to work on, again, a music recommendation problem. So during the first episode, we focused on the data science and machine learning part, so machine learning angle. And we covered data preparation, training, explainability, so really data science.
Yes.
And this week we are going to revisit this example, focusing on the ops angle.
Good. Discussing
this time deployment, monitoring, and much more.
Okay, so we're picking up where we left the example last time, and I think we stopped at training and model debugging and explainability. Okay, so we'll summarize those steps. So if you watch the episode, this is where we are. We're starting to deploy. If you didn't watch it, don't worry, we're going to summarize. Okay. If you want to run this example, it's available on GitHub, of course, and this is the repository. Okay, so take a screenshot. I'll give you a few seconds. And we'll try not to forget to show it again at the end.
At the end.
Okay. All right. So let's start looking at this example. All right. Give me a second here. Okay, here it is. Right. So here's the, you may remember this is organized in a series of notebooks. And so last time we ran notebook 1, 2A, 2B, 2C, and 3. Okay, so data prep training. And we'll try and quickly summarize what we've done last time around. So first of all, Sego, please refresh our memory on what this problem was from a machine learning perspective.
So the idea, just to do a quick recap, we are going to frame this recommendation system as a regression problem. So quite simple way of doing this recommendation system.
Okay.
We are going to use a data set, and the idea is to recommend some song to a user.
Okay.
So for you, heavy metal.
She remembers.
I remember, of course.
And of course, there is no heavy metal in the data set, as you very well know if you watched the previous episode, but I'm not going to complain.
No, not this time.
Well, I will, but
not
too much. Okay.
So in order to do some recommendation system, we need to define each track. So each track has a number of features, like energy, speechiness, tempo, genre, and so on. And so we are going to do some preparation. We are going to aggregate feature and so on in order to see what kind of music each user likes. And after, thanks to Data Wrangler, we are going to concatenate the track feature with the aggregated feature of the author of the review. And finally, we will use the review rating as label, and we try to predict it as a numerical value. So,
okay, all right, simple enough. So So the basic idea is for each individual user in the data set, we compute some aggregated stats to figure out what they like. We call that user preferences, and these become features. Then we have all the song features, which you mentioned, and we join those two, and now we have our data set.
Exactly.
Right? And we have the rating. So we know these user preferences with this song features gave us this review. And we train on that and we predict it. So it's a regression problem. Okay?
Exactly.
All right, super simple. So the data set is reasonably large.
Yeah. If I remember well, it was 140,000 different songs.
Okay.
4 to 50 user or something like that. So enough to learn, because we've got almost 500,000 user rating events.
Okay.
So you can try to learn on this kind of data set. Yeah, exactly.
So data prep, as we mentioned, we used Data Wrangler, and we see the flow here. It's already included in the repo, so you can just run this flow either manually or run it with SageMaker processing.
We use as well SageMaker processing.
Yes, yep, SageMaker processing to automate the execution, but you can also run the flow manually if you want. So we have those notebooks, 2A, 2B, 2C are actually the notebooks for the different data sets for user preferences and tracks and ratings. Okay, so easy enough. So once we have the processed data sets, we push them to Feature Store.
Exactly.
Right? What happens next?
Athena?
Yes.
So yes, we are going to use Amazon Athena to query the 3 features groups, so rating, tracks, and user preference. And after, thanks to Athena, we are going to join the 3 data frames we built and doing like some duplicate dropping and of course splitting.
Yeah, create the files, split them.
Split them for training and validation.
Okay, and then we train as usual, no difference.
No difference.
And we used SageMaker Clarify. SageMaker Clarify for explainability. And we'll look again at Clarify a little bit today. And we use SageMaker Debugger to find problems that happen in the training job. Okay, so this is where we are.
Exactly.
Okay, so we trained a model. We ran some bias analysis, explainability analysis, and now we'd like to deploy. Okay, so let's move on. Let me close those notebooks. We don't need them. And so we start from notebook number 4. So once we have a model in SageMaker, once we've trained a model, we can use it in different ways. Okay, we can deploy to a real-time endpoint, and this is what we're going to do. Okay, an HTTP endpoint, and we can send data to the endpoint to be predicted. So that's what we're going to do today. There's another way, which is called batch transform, where, as the name implies, we run predictions in batch mode. Okay, so we put our data to be predicted in S3, and we run a batch job where the data will be predicted with the model we trained, and we get results in S3. Okay, we'll try to show you this in another episode. Okay, but for today we're going to do real-time prediction.
But it's important to have in mind real-time versus batch.
Yeah, and to expand on this just a little bit, some use cases do not need real-time prediction. Sometimes you want to predict, 10 gigabytes of data once a week, once a month.
Exactly.
So the real-time element is really just not useful at all, and so there's no reason to have an endpoint doing nothing or even going through the trouble of creating the endpoint, taking down the endpoint. You can just run batch mode. Okay, for a lot of applications, actually, batch is completely fine, and it's easier, it's super simple. So you can use that. Right?
And on the opposite, if you need, for instance, if you're doing like some ML model for autonomous driving,
yes,
you
obviously.
you need real time.
Any connected service needs real time,
Real
right?
time,
So
exactly.
if the model needs to be accessible through a web app, a mobile app, or an embedded device, then sure, you need real time. But for a lot of business applications, you just want to predict, and I guess recommendation would be one of those where we want to predict new users every once in a while and new data every once in a while. Maybe we don't need real time. It's up to you to figure it out. Okay, so let's start looking at this. Okay, so first of all, we set up some, we retrieve some parameters and we set up some technical parameters. Nothing really significant here. Okay, and here is where we really start. Okay, and I guess I can close this as well. Yes. Oops. Okay. All right. Okay, so here, what we're doing is we're deploying from a model that we trained in a different node. Okay, so in a lot of cases, we would actually have a single notebook where we go, data prep, train, deploy. Okay, and so the estimator object that we use in the SageMaker SDK to create the training job is accessible all along. So we would go, my estimator.fit and then my estimator.deploy, which is really the vanilla workflow for SageMaker. Here, we're doing it differently, okay? Because the estimator object was created in a different notebook. We don't have access to it. And it's actually a good opportunity to show you, how do I deploy a model that I trained last week, right? I have this model that I like. I want to deploy it again. So in this case, if you don't have access to that estimator, you create a model object, okay? Just like that. And it's super simple. You just pass the name of the container that was used for training. So here we use XGBoost. So we just find the name of that XGBoost container again, and we pass the location of the model artifact in S3. Okay, so a lot of people ask me, hey, how do I redeploy something? Well, that's how. Okay, go and grab the model in S3, pass the container name, and that's it. Okay, and so now we have this estimator object. And now we can call deploy. Okay. So again, if you run all this stuff in a single notebook, you would go at my estimator.fit to train and my estimator.deploy to deploy. Or if you want to redeploy a model, you would just do this. Okay. Recreate, so to speak, the estimator from the model and call deploy. Right? Yeah, simple. Good trick. Okay. So the parameters here are friendly. What's the instance type you want to use for the endpoint? How many of those do you want? What's the name of the model and what's the name of the endpoint? Okay, so once again, manage infrastructure makes it very easy to use this. You don't need to worry about setting up EC2 instances or networking, or it just works. Okay. So if we said, hey, let's deploy on, let's say, 3 instances, automatically SageMaker would create those instances in different availability zones. Load balancing is automatically applied. So, no extra work, okay? No extra work. So that's really super simple. So what happens next is SageMaker will provision that M4 Excel instance, create an API in front of it, create load balancing, etc., etc. And when the endpoint is in service, what you actually have is a prediction API, right? And we can see it if we go to the endpoint section. Here we go. Music. Yeah, we can look at this one. Describe endpoint. And if we go to AWS settings, okay, we see it here, right?
You are right. Cool.
Okay, so an endpoint is a prediction API that you can invoke using HTTPS and whatever invocation format the algo requires. Okay, so in this case, it's the XGBoost format, which you would find in the SageMaker doc. If it was a, let's say, TensorFlow endpoint, then we would use the TensorFlow serving format, etc., etc. Okay. So nothing weird, okay? It's just a managed prediction API running on managed infrastructure. Okay, so that's what we achieved. Now we want to predict, okay? So given what I just said, it means we need to send an HTTPS request in the right format with the prediction data to that endpoint.
Cool.
We could actually use any HTTPS library. right? So if you want to use, so in Python, we could use the, I guess the requests library. We could use curl, we could use Postman, we could use anything in all the other languages, and that would work, okay? But here we'll just keep using the SageMaker SDK. So this actually returns a predictor. Okay, so we could have here something like, my predictor, whoops, I can type, equal blah, blah, blah. Oh, predicator, that doesn't exist, it's predictor, okay. And then we could call my predictor dot predict. Okay, but again, this is a good opportunity to show you how to use an existing endpoint. Okay, so let's say you have a running endpoint somewhere. Okay, it's already been deployed, and you can.
And you want to reuse it.
And you want to use it now. Okay.
Okay.
Again, you don't have access to this workflow. You just have access. You know the endpoint name.
Okay.
You know it's out there in your account. So you would just do this, right? Just like we created a model to access an existing training job, we can create a predictor object to access an existing endpoint.
Okay.
Okay. Just pass the name of it. Okay, and then as you will see, we'll just call predict on this predictor, passing the data. Okay, so again, if you go from A to Z in your notebook, you would go estimator.fit, estimator.deploy, that returns a predictor, and then you would go predictor.predict. Okay, but in real life, different things exist at different times. So you may want to reuse a model, you may want to reuse an endpoint, and this is how you do it. Okay. All right, so the endpoint is running. Now, how about we predict something? So let's try and predict songs for a given user, okay? So let's take, user 11005, why not? And you may remember that we used feature store when we run that example, okay? And so feature store has two elements, right? The offline store, which is really S3, where we can query using Athena, as you explained earlier, to build data sets. And optionally, but we did create it here, we have an online store where we can retrieve features with very low latency from an online store that is not totally unlike DynamoDB, right? And so the low latency element is important because at prediction time, we don't want to be running SQL queries. That's too slow for us. Even though Athena is very fast, we want millisecond latency to inject and retrieve and inject data in prediction requests. And that's what we're doing here. So we're creating a feature store object. And as you can see here, this is the important API, get record, lets us retrieve features from one feature group for a given record. Okay. So a feature group is just a collection of features that correspond to engineered features that we processed earlier. And obviously here, the record identifier is the user ID. Okay. So it's really, it's really key value, a key value API call. Okay. So for this user, send me the record. And this is where we'll find the references, okay, and the features, the preferences, sorry. And this is what we see for that user, okay. And these are the user preferences you mentioned before, okay. So we computed for all the 5-star reviews of each user. We computed average values for all song features, okay. So these are the user features, user preferences. Okay, good. And these are important because we want to predict for this person, not someone else, right? And what do they like?
Tempo.
Danceability, 0.27. It's a very mixed. Okay, so that person likes blues, rap, and reggae. And I won't make any comments. Blues is okay, I guess. Okay, anyway, it's not about my musical taste. Okay, so now we want to predict some songs, right? So we want to see if that user is going to like a bunch of songs. Okay, and this is generally how we do recommendation. We predict a whole bunch of songs, and then we keep the top 10 or top 20. And this is what you see in your playlists, right? Okay, so here we're going to query, so this time we're querying the offline store, okay? And we're using Athena, so very simple SQL query, just give me 1,000 songs, okay, at random from the tracks table. So we run the query, okay? And so now we have 1,000 rows with all the song features, okay? And here, obviously, you would not do this at prediction time, right? You would have this somewhere else, but you would not run SQL queries, okay? So assume we have a list of 1,000 songs, and we want to predict them. So the prediction request needs to be actually a join of those two things, because as you can see, okay, we have 1,000 rows in the prediction requests. So we have all the song features. So this particular song has an instrumental has value of 0.57, etc., etc. Tempo is 87, and so on. Then we joined the user preferences. And of course, they're all the same across the rows because these are the values for our friend number 11005, right? Okay, so these are the 1,000 rows we want to predict. Okay. And of course, we could have one, right? But why not have 1,000? So we make sure they have the right format. Okay, here we're using XGBoost, I think. And so CSV is a good format. It's one of the supported formats. And that's what we apply here. So we basically convert those rows into CSV values, right? Joining all the rows with commas, right? Using fancy Python. Okay, so now we have this prediction request, right? So 1,000 lines of CSV, and we call the predict API, which I already mentioned. Okay, and we call this on the predictor. Okay.
We send the prediction to the endpoint.
And so what happens now is we're really pushing we're posting an HTTPS request to the URL that we saw here, right? In this tab. Okay.
Runtime. Okay.
Okay. That's what we're doing. Okay. So even though we're calling predict, it's really it's really HTTP posting to that. Okay, and again, if you don't want to use the SageMaker SDK, and that's totally fine, you can use any HTTPS library and post that data to that URL in CSV format, and it'll work, right? Okay, so the result is by default is a JSON answer. We could pass an accept type actually here that says text CSV if we wanted CSV reply, but I guess JSON's fine. And what do you know? We're getting 1,000 ratings. Okay, exactly what we expected. Okay, so values between 0 and 5, or is it 1 and 5? I don't know. I don't remember. 1 and 5. Okay, and so we see a bunch of predictions. So, and this took just a few milliseconds. Okay, so sent an HTTP request in endpoint, got the answer. That's it. So that's what you need to do if you want to integrate endpoints into your app. So let's say we invoke this from, I don't know, a web app, a music service, something like that. What we would do next is, of course, we would not display 1,000 songs. So we'd probably display, I don't know, top 10, top 50, whatever it is. Find the top 50 scores here, using a bit of pandas magic for sure. Match that to track IDs, which we know because we know where those songs came from, and find the list, the top 50 track IDs, and then pass this to a web app that will go and, find all the metadata for the songs, the genre, the title, the artist, etc. Right? And show this in your favorite music app. Okay?
Perfect.
So pretty simple, no drama. Okay, so I guess the bottom line here is the vanilla workflow would be, create your estimator, estimator.fit, estimator.deploy, retrieve the predictor object returned by this, call predictor.deploy, predictor.predict. Okay, here we saw how we can reuse a model, how we can reuse an endpoint. Okay,
Cool.
that's as much as you need to know for real-time endpoints. There are some more advanced configurations. I guess we'll try and discuss those in future episodes, where you can have different variants of the same model running on an endpoint for A/B testing.
A/B testing, yeah.
We can do multi-model endpoints for cost optimization, and we can load and unload models on demand. So you could run 1,000 models on the same endpoint, not all at the same time, probably. But if you want to run a single endpoint and pay for a single endpoint, you can do that, load and unload dynamically. There are lots of configurations, but this is really the main one here.
Main steps. Yeah.
Okay. All right. So I think that's it for. Did I forget anything?
No, I think
we're good.
It's
okay.
yeah, good.
Okay. So let's move on. So in the previous episode, you may remember we ran bias analysis and explainability pre-training, so on the data set. And we did this using SageMaker Clarify, right? As it turns out, SageMaker Clarify can do the same on models. Okay. Post-training. Okay. So I don't think we discussed it, and maybe if we did, then okay, we're gonna repeat ourselves, but that's okay. I think it's important to see this. Okay.
It's very important.
Yes, it is very important because the algo could have an impact, and the training process could have an impact on bias, right? And may probably explainability, I guess. It could make it better, it could make it worse, or it could do nothing.
It could do nothing.
Or a combination of those. Okay, so it's good to know if you have some potential bias in your data set. It's good to know what feature importance is in this data set, but you want to check this again after training. Okay, and you could think, well, but I've got my endpoint, so why don't I predict stuff with the endpoint and then I'll see, right?
Yeah.
But so you could do that yourself, but in fact, the SageMaker Clarify service lets you do that automatically. So we can run, okay, again, go to the episode 1 for all the details, but if you add this model config to your Clarify config, job config, passing the model name, it's going to run the analysis, not only on the data set, which we're asking for here, okay, but also on the trained model. And in fact, it will deploy this model automatically for you. It creates a temporary endpoint, right, or shadow endpoint that is used only for the Clarify job, and then it takes it down automatically, right? So you don't have to deploy a model to run by a bias or an explainability analysis, right? It's done automatically. Okay. So once we run this job, then we have results. I mean, and we have local SHAP values, and I mean we saw all that stuff. Okay. And we run this explainability job, etc., etc. Okay. So I'm not spending too much time, but I just want to highlight this fact here. Okay. So if you can run bias and explainability analysis on a model, you just don't need to deploy it yourself. It's already done for you. Okay. All right. Just a little fact on bias analysis. Okay. So going back to our endpoint. Okay. So now we have a live endpoint, and we're predicting. Okay. Good. And it's recommending music. Just not the music that I like, but it's okay. It's lots of you out there will be happy with the music. Lots of things could go wrong.
Oh, yes.
And these are the best because they're an opportunity to learn, right?
Yeah, exactly.
So what is model monitoring and why should I care?
I think it's super important when you go from research or like this kind of stuff during the data science aspect, and after when you put into production a model, you want to know what's happened with real data and how your model reacts when you send it new data. And I think this is the reason why SageMaker Model Monitor brings a lot of value to your pipeline, because it's gonna help you to monitor what's happened under the hood once your model is live or using real life data.
Okay, so let me play devil's advocate for a second. So we trained, right? we have a very nice data set. We cleaned it. We love that data, and made really something good out of it. We have a test set. We have we did k-fold validation. We use all these fancy techniques, and we have good metrics. So why would that model go wrong in production? What could be different in production?
Your data.
Always data.
Always data.
Okay.
Because what you described is what's happened in a perfect world. Everything is clean, everything works well, and so on. But most of the time, when you put into production, and this is the important part of the MLOps angle, is what's happened when you put real data in this beautiful, perfect world you created.
Okay, so real life data
could change.
Could change, right?
Yeah.
So it could be ugly, first of all. could be messy, and it is. I shouldn't use could. It will be messy.
Yes.
So it's gonna miss features. It's gonna have mistyped features.
Maybe it's scaling.
Scaling problems. Yeah, I love those.
Problems.
I have great memories of scaling mistakes on currency exchange rates. I know. Yeah, that was very messy. Okay, yeah. So you find out later that some upstream app is multiplying your amount by 1,000 because why not?
Why not?
And you know, and it breaks a lot of stuff. Yeah. So scaling issues and just generally the fact that data can change over time.
Exactly.
Right? I mean, the reality that your training data is describing could just change, right?
Exactly. It's a dynamic.
From a statistical perspective, maybe you have the age distribution of your users is changing. Maybe the location of your user is evolving as you're opening new markets, and those locations have different properties. So okay, so the fact is you don't know, right? You don't know what you don't know.
But you want to monitor.
Yeah. So the only option is okay. How do I keep an eye on prediction quality? And how do I figure out that data drift is happening, and something is different, and it could be even your bias.
Yeah.
Maybe bias is increasing your data set. You don't know, right? Okay. So that's why we need model monitor. So model monitor can be applied on at endpoint creation time, or it can be applied on an existing endpoint. Okay. You can, if you have a running endpoint, you can update it to apply model monitoring. Okay, so let's take a look. So the first feature is, of course, as you explained, we need to understand that data, the real life data, right? So we need to capture it. So the first step is enabling data capture on the endpoint. Okay, so let's see how we do this. And as you can expect, capture data will be stored in S3, okay? And this is the data capture config object. So it's not very hard. Enable capture true. Okay, meaning yes, please do this. Okay? It sounds silly because it's like, yeah, I'm creating the object, but keep in mind, you could use the object to disable capture. Okay? So there you go.
Okay.
Sampling percentage. So how much of that incoming data do you want to grab? I think the default value is 100%, okay, unless it changed in recent SDK versions. So here, let's say, well, 25% is fine. Where do you want to store that stuff? In S3? Do you want to encrypt that data using Amazon KMS, Key Management Service? Do you want to capture requests and or responses? Okay, I think again by default we capture everything. What's the content type that you want to use to store data in CSV format, and what's the content type for JSON? Okay, so there's a bit of a caveat here, right? And this has bit me in the past. So you can only capture CSV and JSON data, and it's flat JSON. Okay, so if you have nested JSON, it's not going to work. So data is actually going to be captured, but you'll run into issues later on. So if you just want to use the capture mechanism, it's actually okay, but for the monitoring feature, it won't work. Okay, so CSV only, flat JSON, And again, only one prediction
per request.
Sample per request. Okay, so the example that we used earlier, where we sent 1,000 lines, is actually going to break the monitoring feature. Okay, but let's pretend we did not do that.
We did not.
Okay, okay, if you follow that advice, CSV flat JSON, one
Prediction.
instance per prediction request, you are good to go. Okay, fine. And next, okay, we apply the data capture config to the endpoint. Okay, and it's as simple as this. Okay, we recreate that predictor object. Because remember, it's in another notebook, right? And we just call predictor.update data capture config, passing the config, right? It's a lot of data capture config, but it's really what we're doing here. So it's all good. The name's good naming, right? And then we just wait for the endpoint to be updated. One thing to know is the endpoint actually stays up, right? If when you do endpoint updates, they are non-disruptive.
Okay.
Okay, so you can keep predicting. That's fine. No downtime. Okay. Okay, so it runs for a few minutes, and now the endpoint is starting to capture data. Okay, so if you go at the S3 location that you specified, you'll start seeing files.
Okay.
Okay, and this is useful in itself, right? Because you could use that data to to test your models, for back testing, or and it's already good to have that live data. You could add it to your training sets, whatever. So that's already nice. Now, the second step is baselining. So baselining means I need to figure out the statistical properties of my training data, of my reference data, so to speak, right? We assume your training set has been given a lot of love and it's perfect, okay? And you'd like to compare incoming data to that, okay? All right, so again, baseline results will be stored in S3, and creating a baselining job is not difficult. Here we're using the validation set. Okay, and this is what we're doing here. So we're creating a baseline using the data set, the validation data set, mentioning that this is a CSV data set, and where to store results. Okay, so here's my golden data. Build a baseline from it. Okay,
and compare real data, new data to this.
And so this runs for a few minutes. Okay, and this will actually we don't need to know too much about the processing job, but we do need to know about the results. So we can retrieve the baseline stats that SageMaker computed. So for all the columns in that data set, we see the inferred type. Okay, we see how many values are present, right? So do we have missing values? Meaning, would it be okay in my real life data to have some missing data, right? If some of your columns have a bit of missing data in the training set, I guess it's fine if you have a bit of missing data in your real life data, right? So how many are present, how many are missing, and then stats, the mean, the sum, standard dev, and KLL. So I'm not gonna go. We don't have time for that. It's a great statistical tool to describe data distributions.
Exactly.
Okay, KLL sketches. Okay.
Your favorite one.
Yeah. It's very interesting, but we don't have time for that. So go and look for KLL sketches, and you'll figure it out. Okay. Okay. So we know about those features, right? And again, this is what our real life data should look like. So now the next step is to enable monitoring. And this is done with a monitoring schedule. And a monitoring schedule is exactly what the name says. So it's now we have all the pieces that we need. We have the endpoint. We have capture data.
Yes.
We have the baseline. And so every once in a while, okay, and in this case, we do it daily, okay? I think we can do it hourly as well, if I remember. we're going to look at the statistical properties of the capture data and compare that to the statistical properties of the baseline data. And if something doesn't match, it becomes a violation and you have a violation report. So you go, and in the morning you get that in your inbox maybe, if you configure that. Or you see it in a log somewhere and you spend a very interesting day figuring out, who the hell sent me that crap data that's breaking my model, right? Which is what data scientists do anyway.
Exactly.
Right? Fix bad data before training, fix bad data after deployment, and try to do some useful work in between. Yes? Am I depressing you yet?
No.
Okay, so we create the monitoring schedule and then, that's it. Okay? And so now every day we're going to run those analysis, and if some crap data is sent to the endpoint, we'll have a violation report. Okay, and we can go and see, okay, that item, instance had this problem, and then of course you need to go and figure out what's wrong, right?
Super useful.
Yeah, super useful. And you see some metrics, and you can monitor. You can monitor your metrics, and you can monitor your bias metrics and other metrics, and over time see how well the model is doing or not. Okay. All right. So I think we're almost done.
Just for the last.
So just a sneak preview. So the next step, now that we have everything, data prep, training, bias analysis, model deployment, model monitoring, model debugging. Of course, the next step would be get rid of all those funky notebooks and do everything as a very sleek, nice, and dare I say sexy pipeline, okay? And this is exactly what we're going to do in the next episode, okay? So what a cliffhanger, okay? So this is what we'll do. We'll walk through an end-to-end pipeline where we create all those steps, right? And just link all of them and build a very cool pipeline that we can execute and visualize, etc. Okay? But that's for the next episode, right? We're almost out of time, but we are on time, so that's good. So
screenshot time.
Yes, thank you. You're saving me again. Okay, so this is the example we looked at again today. Okay, very cool example with music rec. Okay, and so we completed the overall workflow. Okay, and we saw how to deploy, how to predict, how to use the online store, how to apply model monitoring. And so the next step is, again, automate all of that stuff. But we'll show you this next week on another example, but we'll quickly show you what it looks like also for this example, right?
Okay.
Very cool. So I hope you learn a few things, and again, feel free to run these notebooks yourself. Sego, thank you so much.
Thank you, Julien.
Thanks everybody for watching, and we'll see you next week with another episode completely dedicated to pipelines.
SageMaker
See you soon.
Bye-bye.